When you're parking your car, it's always useful to know where you are in relation to obstacles. Listing a bystander to provide you with feedback is one solution to this problem. What is feedback? Feedback is a method of control in an uncertain system. Output is sampled, transformed, and added to the input. Like when you're parking that car, your body is sampling the distance to the curb and you're adjusting your speed accordingly. Here's a basic diagram of how feedback works. The input signal goes through the amplifier to the output, but some of that output goes through the feedback and is put back into the amplifier. In the context of electronics, feedback is a tool used to stabilize amplifiers amongst other applications. Now let's try to attempt to model this. The signal going to the load is XO. You can say XO is equal to AXI, right? Because it's going through the amplifier A. But XI is actually the input signal XS minus the feedback XF, which is some multiple of XO. So we say that XI is equal to XS minus BXO. So going back to the first equation, we can say that XO is equal to A outside of XS minus BXO. XO is on both sides. To solve that, we can rearrange and get XO on XS, the gain, to equal A on 1 plus AB. Expanding and taking AB XO to the other side, we can rearrange to find the basic feedback amplifier equation. There are two main types of feedback, namely positive or regenerative, and negative or degenerative. Negative feedback is when the feedback is subtracted from the input, such that Xi is equal to XS minus XF. On the other hand, we have positive feedback where the output is added to the input, such that Xi is equal to XS plus XF. Feedback is used to control amplifier circuits, which are renowned for being uncertain systems due to their variance as a result of external factors like temperature, frequency, and manufacturing variations. Feedback can alter the performance and behavior of a circuit in many ways, including stabilizing gain, but at the same time lowering it, noise reduction, reducing distortion as well as desensitizing gain, and modifying both input and out resistance as well as extending bandwidth. There are 4 ways to implement feedback in an amplifier circuit. They are named differently depending on how they sample at the output and how they affect the input. We draw your attention first to a voltage feedback amplifier. Looking at the diagram from left to right, we see 2 characteristic configurations, a series configuration and a shunt configuration. This results in a circuit best described as a voltage-controlled voltage source. That is, the voltage taken from the output of the amplifier is multiplied by some factor to increase the potential difference at the source. This has the effect of increasing input resistance and decreasing output resistance. The second circuit we will examine is called a current or shunt series amplifier. You'll notice that this has the opposite configuration to the voltage feedback amplifier we looked at earlier. This behaves as a current-controlled current source. Much like the voltage-controlled voltage source, the current at the output is multiplied by a factor and returned to the input. This topology has the benefit of stabilizing current gain, however lowers input resistance and raises output resistance. This is because the feedback current, IF, subtracts from the input current, IS. Next we look at a transconductance feedback amplifier. We see a series connection, thus the name. The series connection at the input increases input resistance while sampling at the output increases output resistance. The last output configuration is comprised of 2 shunt connections. In the transresistance amplifier, input is current while output is voltage. The shunt connection at the input causes the input resistance to be reduced, and the shunt connection at the output stabilizes the output voltage, thus reducing the output resistance. And that covers the 4 main feedback topologies.